Welcome back to part two. Most of the time I won't have part two of notes, but today I do. So we're going to talk about some definitions first. So the first thing we're going to talk about, this is part two, talking about intervals on a number line. So an interval, don't make fun of my voice for cracking, an interval is part of a number line without any breaks, and we're going to talk about a few different types of intervals. The first one is called a finite interval. You might want to pay attention to that because it may be on a quiz. It has two endpoints, A and B, that are both real numbers. This type of interval means that x is bounded. I'm going to use that word quite often, that we have a variable x that's bounded between two numbers, which may or may not be included in the interval. How can we tell if it's not included on the interval? Well, on a number line, we would see an open circle. Circle point. We would see a closed circle if it is included, and an open circle if it's not included. So what that would look like is on a number line, we would have a point A and a point B, which are two real numbers. So let's just say, for instance, we are closed on A and open on B. This x can be anywhere in between A and B, including it could equal A, but it cannot equal B. It can go all the way up and get really, really close to B, but not be B. Okay? Let's see. Okay. We also have an infinite interval. And this is where you are unbounded at one or both ends. So typically you would just have, on a number line, you would just have one number and you would be shading in one of the directions. So something like that can be an open circle, and we can shade like this side of the graph. That would be considered an infinite interval, where we're continuing to infinity or negative infinity, something like that. Okay, so here's some different notations that you're responsible for knowing for. So all real numbers from A to B, including A and B, we're going to see what that looks like real quick. So we're going to use the A and B examples again. So on a number line, let's write A and B. And here we say we want to include A and B. So that means on A and B, we're going to write closed circles, and then we're going to shade in the middle. This is saying x can live anywhere between them. Inequality notation, this is how we write this. So we start with our smallest number. Let me write a different color since that's green. Start with our smallest number, A, because that's on the far left. And then we're going to write these inequality alligator symbols facing away from the smallest number towards our variable x, which also is smaller or equal to whatever that number b is. So that's how we would express that in inequality notation. Set notation looks very similar, but it has this fancy little bracket, and then it has this little notation right here, which this just means x such that x is an element of all real numbers. So you draw this little brackets followed by the variable x, then this little bar here followed by another x with this little weird looking e, and a capital R with a line in front of it for all real numbers. And then you just copy what we just wrote for inequality notation, which is kind of nice. And then interval notation looks like this. You have your smallest number, comma, your largest number. And it goes in that order. Notice we don't have a variable in there. It's just the smallest number, the largest number. But we do have, in this case, brackets. And you can also have parentheses. And we'll talk about what to use when here in a second. This next example says all real numbers greater than A. So on a number line, let's put A somewhere, anywhere on here, and we want to talk about all real numbers greater than A. So what would be bigger than A, the left or the right of this number line? Well, these numbers, as the number line goes out here, are getting positive and getting bigger, and these are negative. So all the real numbers that are greater than A would be right out here. That's telling me that X can live anywhere over here. In other words, X or A, we can even draw x down here so it looks a little easier. If x can be anywhere in here. I don't want to draw a point right there, but x can be anywhere in the shaded region, and x is bigger than a. That's what that's saying. So that's how we would write that actually for inequality notation, is a is less than x, or we can write x is greater than a. It doesn't matter. Set notation. Set notation looks the same, except we have to copy down this beginning stuff that's kind of specific, more for like theory type of things. So I'm going to go ahead and write this as x is greater than a, just so we can see that that's the same thing. I'm going to write that a little bit different, but either way, the inequality is still facing x. And then here in interval notation, my smallest number still comes first, but notice I have a is strictly less than x instead of less than or equal to. So what I'm going to put here for that first letter is a parentheses instead of a brackets. And then I don't have a b value because my graph is going on and on and on forever. So here in interval notation, we actually use the infinity symbol to represent that. And we don't use the infinity symbol when we're talking about inequality or set notation. So, and notice I also put parentheses around infinity because parentheses indicates that you don't touch it, you just get really close to it. Well, infinity is a concept, not a number, and you can't actually touch infinity. So we put parentheses around infinity. Infinities don't get put in inequality and set notation. Okay, lastly, all real numbers less than or equal to a. So if we're plotting a number line, let's draw a on the number line and think about where that would be, to the left or to the right of a. Well, if everything is less than or equal to a, I need a closed circle, and everything needs to be shaded to the left. The way that would look on a number line is x is less than or equal to a. X can be anywhere over here, which is smaller than or equal to a. Set notation, do this little fancy stuff. Oops. I'm going to be quite honest, like most students after this first test don't write set notation, and that's completely fine. I wouldn't either. Typically, my favorite notation that I will start writing as we continue with the semester is I will write this. I will write interval notation always. It's just my preference. So interval notation here, our smallest number in this case would be the x, but x can continue forever in the negative direction. So I'm going to start by writing negative infinity this time, and then comma a, and here I'm going to use brackets because it's less than or equal to a. Okay. All right, let's do a few examples. I'm not going to do all of these, okay? I'm just going to do kind of one for the sake of time. But complete the table by writing I'm going to use the word bounded here, by using the bounded finite interval, using set, inequality, and interval. So if this is shaded here, that means x is bounded between. I'm not going to write this whole thing for sake of time, but the description of this interval is x can be anything between -3 and 2, including -3 and 2. So, in other words, in inequality notation, we'd write the smallest number first, followed by our inequality less than or equal to x, which is less than or equal to +2. Set notation, just use that fancy stuff, x such that x is an element of all real numbers, and just transfer what you just wrote like that. Interval notation, we use brackets when it's included, parentheses when it's not. You write your smallest number first, your largest number second. They both have brackets because they're both included. So I'm going to go to the next one. All right, here we have, I'll do the one on the right this time. This one, the description of the interval would be all numbers greater than 2. X can be anything greater than 2. X can be anything over here because it's a shaded region. In inequality notation, we can start by writing 2 since 2 is the smallest number of the set and point the inequality towards the x. Set notation, x such that x is an element of all real numbers. 2 is less than x, or x is greater than 2. Interval notation, we write the smallest number first, which the smallest number is bounded at 2. And we use parentheses because that is a open circle. And we're unbounded on the right. So if we're unbounded on the right, that would be positive infinity. It continues forever. So that would be interval notation. Okay, let's do a brief reflection real quick. So consider this interval. This is basically illustrating the fact that this entire line is shaded. What do we suppose are the numbers in this interval? Well, they would be all of them. like if this entire number line is shaded, then everything, x can be anything on here. So we can write that as all real numbers or use just that symbol, which is a capital R with the line in front of it for all real numbers. I want to represent this using interval notation as well. Interval notation, we would write this. The smallest number in our set would be considered negative infinity. And the largest number would be considered positive infinity. That's saying all the numbers. That's the same thing as saying all real numbers in interval notation. What do these intervals have in common? Well, I have this diagram on the next page, but basically, just to kind of point out, obviously they all are bounded. They're finite between the point 0 and 5. So x can be between those. The brackets mean that they're closed. The parentheses means that they're open. So those are some similarities and differences. Okay. The symbol U represents the union and combination of two sets. What do you think the notation negative infinity to 0 means, unioned with 0 to infinity? So let's just plot the only number that we see here as 0. Okay, and let's just think about this for a second. What does that mean? How do we sketch that on this number line? Well, this is saying that negative infinity is the smallest number, meaning furthest left of this, and 0 would be the largest. So that would shade all of this. And we would put an open circle here, because there's a parentheses right here. And then let's go to this other side real quick and look at that. This is saying 0 is the smallest number in the set, and positive infinity is the largest. So that's going to shade all of this. Is that all real numbers still? Because what does this open circle represent? Do we touch 0? No, we do not. So this would be all real numbers except 0. We can say x cannot equal 0, or we can say all real numbers except 0, or something along those lines. Okay. So to summarize, this is a kind of a cheat sheet, what to use when. So in inequality notation, when you have something that's unbounded or an open circle, we use these symbols. Same thing for set notation. Use those symbols. Now in interval notation, when something's open, you use parentheses. And you also use plus or minus infinity. You don't see infinity show up typically when you're talking about inequality and set. It shows up in interval notation. You write those into the brackets when you're unbounded. And a closed circle, for inequality notation, you use these symbols. Less than or equal to, greater than and equal to. And the same thing here. And if we're closed and we're bounded on interval notation, we use brackets. Okay. All right, so your homework assignment. Your first homework assignment is to complete Unit 1, Assignment 1 in Delta Math. This is for a grade, and it's how I'm taking attendance. So anyways, I'll talk more about grading in class as we continue on. But good luck with that assignment. I'll be here. Let me know if you have any questions. And have a good day. We'll talk to you next time.